Oblique projection or oblique drawing. Oblique drawing is the simplest method that can be used to portray objects pictorially. However, it is only recommended for objects that are not too large and whose shapes are not overly complicated. Large objects and objects that have complex shapes often appear distorted or unnatural when portrayed by this method. Sabi rito, ang oblique projection ay ang pinakasimpleng paraan ng paggawa ng pictorial drawing dahil ang surface ng direktang nasa harap ng mga viewers halos kamukha ng front view sa isang orthogonal drawing. Gayunpaman, ang mga mukha lamang ng mga bagay ang pinapakita sa totoong laki at hugis ito. Types of oblique pictorial views. When an oblique pictorial view is prepared to exact dimension of an object is called a cavalier's projection. In many instances, however, a cavalier projections make objects appear distorted. To reduce distortion, the dimension of receding features of objects are drawn half-scale. When this is done, the resulting pictorial views are called cabinet projection. Nasabi dito na mayroong dalawang particular na anyo ang oblique drawing. Ito ay ang cavalier at cabinet projection. Makukuha ang cavalier projection sa pamamagitan kapag ang anggulo sa pagitan ng oblique projector at ang plane of projection ay 45 degrees at ang real projection ay true to size. Ang cabinet projection ay isang pahilig na projection kung saan ang haba ng mga linyang umuurong pabalik ay hinaharap. Narito ang dalawang uri ng oblique projection. Ito ay ang cavalier's projection and cabinet projection.
In this video, we're going to take a look at oblique drawings, and we really have two different types of obliques that we're talking about. We have cavalier and cabinet, and they start off the exact same way. There's one minor difference that actually winds up being a pretty big difference when it's all said and done. But let's start off with getting it ready to go so we can get to that difference. And again, the point of an oblique drawing is to kind of give you a different view of how an object looks. It's not an isometric, but it still shows all three sides. And it's not a 1 or 2 point perspective, but it again gives us another way to view our items. And the more ways we can view stuff, sometimes that just helps being able to visualize it a little bit easier. So we're going to start off with the cavalier one, and then we're going to go to the cabinet. And the only difference between these two is the depth of the object. And we'll get into more of that in just a second. But to begin with, the cavalier drawing that we're going to start off with, we want to start with the front view. So in this case, we have our white cube here, and it's going to say, let's say, a 1-inch white cube. If each of our grid spaces is 1/4 of an inch, then we need to go down 4 grid spaces. So let's start off in our bottom left-hand corner, and I'm going to go up 1, 2, 3, 4. From there, I can go over 4 spaces, 1, 2, 3, 4, and then I'll just finish off the box to make sure that we have everything set up and ready to go. So I have my front view totally done. It's 100% correct. It's ready to go. And that's as complicated as this aspect of it gets. So we have our front view done. It's ready. Now the only thing we need to do is add on our depth, because an oblique drawing gives us a 3D kind of feel. So now I'm going to take all of my outside corners minus the one that would cross over itself, and we're going to go back a full depth. This is a cube, so we're going to go back 4 grid spaces. In a cabinet, we'll go back half of that, and we'll show you what the difference looks like in just a moment. I'm going to go back 1, 2, 3, 4, 1, 2, 3, 4, and then 1, 2, 3, 4. The last job on here is to connect all of your dots, because you really want to get something that looks like an isometric. It's just a little different. So I'll go in, connect 1, and then I'll finish off my top view. Now if you notice, I get something that looks very, very much like the isometric. The difference here is my lines are at 45 degrees to show depth. They're not at 30 degrees, which is what an isometric uses. And it looks a little bit skewed, a little bit bigger than what the actual cube looks like. That kind of comes important because with the cube, the Cavalier doesn't show off as being as big as what it is. But in drawings that have a lot more depth than what this one does, where it's equal, they show up a lot fatter, for lack of a better term. They look a lot wider or deeper than what they actually are. Again, the front view is the exact same. It is just a 1 inch by 1 inch in this case, but the depth is what changes. Now, in a cabinet drawing, we still have the depth changing, but the difference here is that it's going to change by half, which gives us a more realistic looking image generally. 1, 2, 3, 4. So I'm just going in and drawing my front view. This step does not change depending on what we're doing. So it's always the same here, no matter what we are drawing our front view, and it looks beautiful. All right, again, the exact same front view. There's no difference between the two. They are set the same. Now the difference comes in where the depth is what actually changes. Front view stays the same, depth changes. In this case, on a cabinet oblique drawing, we're going to go half of the depth. So on our previous one, we went 4. On this one, we're actually only going to go 1, 2. And I'll do that on all of the corners that are visible. And then I'll go in finally and connect the dots. Now, if you look at it, it looks like the cabinet is a lot shorter and smaller than what the Cavalier is. Again, the front views are the exact same. The only thing that's changed here is the depth. Our depth is half on a cabinet. It gives us a much more realistic looking drawing. If you look between those two, the Cavalier one looks a lot fatter, it looks a lot more exaggerated, and a little bit more out of focus or out of kind of skew than what the cabinet is. And that's really what a cabinet drawing is there to do. It's there to be able to set up and figure out how big something is. The nice thing with the Cavalier is you could just stick a ruler on there and measure everything and have all of your dimensions and they're 100% correct. On the cabinet drawing, you can measure the top and the right view incorrectly because the depth is half. The front view is always going to be the same, but you need to make sure you remember that the depth is what's different. So that's kind of the setup. That's how these oblique drawings work. We'll do some more of these in a little bit, but this is the basic stuff, and please let me know if you have any questions. Thanks.
Step in constructing an oblique drawing. To prepare a covalent projection of an non-cylindrical object. First step, visualize the object in an position that shows its shape to best advantage. Receding edge and surface can slope to the left or right. The direction is matter of personal choice. Nagpapakita sa larawan na ang pag-atras ng gilid at mga ibabaw ay maaaring dumulas o madulas sa kaliwa o sa kanang bahagi. Second step, lightly construct an object using the overall dimension of the object. Receding edges can be drawn at any convenient angle to the baseline. 30 degrees and 45 degrees are commonly used angles. To show the top surface of objects more clearly, an angle of 45 degrees should be used. Dito naman, nasasabi ang pagbuo ng kabuuan ng kahon na naaayon sa kanyang sukat at sa mga paatras na gilid ay maaaring iguhit na sa anumang anggulo sa baseline na 30 degree at 45 degree dahil karaniwan itong ginagamit sa mga anggulo. Third step, construct the basic shape of the object. Tumutukoy naman dito sa pangatlo ay ang buuin o mabuo ang pangunahing hugis ng isang bagay. Fourth step, remove unnecessary construction line to reveal the basic shape of object. Construct the web. Dito naman sa pang-apat, ang sabi dito is tanggalin na daw yung mga unnecessary line para makita na yung shape ng object. Step number 5. Construct the hole in the rear upright section. Check to see if the rear edge of each hole will be visible. When the rear edges of holes can be seen, they must be shown. Construct the rounds. Ang sabi naman dito sa step number 5 is gumawa ng mga butas sa likurang patayo ng seksyon. Siyempre, maaari na nating suriin ang huli upang masuri ang gilid ng bawat butas kung ito ba ay makikita. And the last step, remove unnecessary construction lines, complete finish line work to obtain the oblique pictorial views. Shading can be added to emphasize the three-dimensional effect. And last, dahil nagawa na nga ang mga holes sa rear upright section, katulad sa step number 4, tatanggalin na yung mga unnecessary construction line para makita na yung pinakang oblique projection or oblique drawing. So, nasabi ko na ang steps sa non-cylindrical object. Then next is to prepare a Kabbalah projection of cylindrical object. Ang cylindrical object naman ang itatakal ko kung ano yung bawat step niya. First step, visualize the object in position that shows its shape to best advantage. Receding edges and surfaces can slope to the left or to the right. The direction is matter of personal choice. Ang tinutukoy naman dito sa step number 1 ng Kabbalah projection of cylindrical object is ilarawan sa isip ang bagay sa isang posisyon na nagpapakita ng hugis nito sa pinakamahusay na bentahe or tapos ang mga urong na gilid at ibabaw ay maaaring madaos-os sa kaliwa o sa kanan. Tapos yung direction ay ng isang bagay ay personal na pagpili. Second step, establish the vertical and horizontal center line of the front face of the hub. Draw the front page of the hub. Lightly draw the axis of the object. Any angle can be used, but 30 degree is preferred. Sinasabi naman dito sa step number 2 is maaari din gamitin ang anumang anggulo. Ngunit mas okay syempre yung preferred dun sa 30 degree. Third step, measure the length of the hub along the axis. Draw the rear contour of the hub. Draw tangent line to complete the hub. Ang sabi naman dito sa step number 3 is susukatin naman yung haba ng hub sa kahabaan ng axis, tapos yung pinakang likurang tabas o bahagi ng hub ay iguguhit para naman makumpleto ang hub. Guguhit naman ng mga tangent na linya. Fourth step, draw the front edge of the flange. Measure the thickness of the flange along the axis. Draw the rear edge of the flange. Draw tangent line to complete the flange. Tinutukoy naman dito sa ika-4 is iguhit ang harapan ng flange. Pagkatapos, sukatin ang kapal ng flange sa kahabaan ng axis. Iguhit naman yung likuran ng flange. Then, gumuhit ng mga tangent na linya para makumpleto ang flange. And the last step of Kabbalah projection of cylindrical object is remove unnecessary construction line, complete finished line work to obtain the oblique pictorial view. Shading can be added to emphasize the three-dimensional effect. At ang pinakang huli naman, ang sabi dito sa pinakang huling step is alisin na ang hindi kinakailangan linya ng construction. Tapos, kumpletuhin na ang natapos na line work para makuha ang pinakang oblique pictorial view. Maaari namang magdagdag o idagdag ang pagtatabing para maging bigyang diin sa 3 dimensional na effect.